Welcome to the new and improved Engineering Olympics. This year, you've decided to take on the Engineering Technology Club's first ever design challenge, where you'll be designing, building, and testing a sailboat, like this one, or like this one. To design your sailboat, you'll be given the following electronics: a 9G servo, a Wi-Fi capable Arduino, a battery pack, and some jumper wires. Electronics are pretty set in stone. However, materials for your sailboats are not. You and your team can use any material that you think will set your boat sailing.
Alright, so now we're going to go over some things you need to take into account when designing and constructing your sailboats. So, the first thing we're going to go over is the importance of a counterweight and how to design your boat to be the most stable when there are strong gusts of wind or choppy currents in the lake. So, let's say we have our sailboat right here. Pretty simple, basic design with no counterweight. So, the center of mass of this sailboat, or the point at which the sailboat were to balance if you were to hold it in your hand, is going to be somewhere in the middle of the sailboat. Let's say right there. So, gravity is going to pull down on the center of mass, and you're going to have a force vector that is straight down. Now, as we know, the sailboat is going to float in the water, so there needs to be an upward force. And that upward force acts in the center of mass of the water that is displaced by the boat. So we have our water right here. And the center of mass of this water that's being pushed to the side by the boat is somewhere, let's say, right there. Critically, it is lower than the center of mass of the boat. So this force is going to point upward, directly opposing gravity. We'll call this FB, and this is FG. Now, some of you in your physics classes will call this the normal force. It's similar to the normal force. However, it acts in the center of mass of the boat, or of the water displaced. Sorry, not the boat. So now, let's say a strong gust of wind comes, and our boat is tilted over to the side. In the water, of course. Now our center of mass is still in the same spot, somewhere right about there, and it's still going to want to act downward. And our center of buoyancy, or the center of mass of the water displaced, is going to be roughly in the same spot as well on the boat. And that is going to act upward as well. Now you'll notice that if this FB is to the left of the FG, that the boat is going to want to do this. It's going to want to tip over. That's because you have the force gravity pulling down to the right and the force buoyancy pulling up to the left. It's going to want to tip this boat over, and this boat's ultimately going to sink. Now, if we design our boat with these basic physics principles in mind, say like this, and we have a counterweight somewhere like that at the bottom, our center of mass is going to be much lower on the boat. It'll be somewhere around here, depending on how heavy we make the counterweight. So we're going to have force gravity acting like that, and force buoyancy acting upward like this. and then we have our water again. Now, when a gust of wind comes and the boat wants to tip over, our FG is going to be over here. And our FB is still going to be in the same spot because it's the center of mass of the water displaced. And that's going to be much higher up. So now our boat is going to want to tip in the opposite direction. And that's because we have forced gravity pulling the boat down on the left side and forced buoyancy, sorry, it should be FB. Forced buoyancy pulling up on this side. So therefore, the boat is going to want to self-right and correct itself so that way it's not going to sink. So that is why a counterweight is important in maintaining stability of your sailboat and making sure it's going to last the longest. Now, what's also important to keep in mind is that you don't make the sail too big, otherwise the little servo is not going to be able to properly turn it and direct it in order to catch the most wind. So you want to make sure that this sailboat is relatively small. And yeah, we show an example in the video. And yeah, good luck, guys. So in the email, you should have gotten this GitHub link that will take you to the page with written instructions on how to set this up. And this is basically going to be the video tutorial to these written instructions. And okay, so in order to first get started, our first step is going to be to download this repository. Now, I've already downloaded this to my desktop right here. So that's step one already done. Next, we're going to need the Arduino IDE. And so if you click on this link, it'll take you to where you can download the Arduino IDE. You have to download it from their website. You can also get it from the Windows Store, but if you get it from the Windows Store, the ports won't be recognized on your computer and it'll cause some problems. So the easiest way to have the least amount of errors is just to get it straight off their website. And you know, it uses all operating systems, whether you're on Windows, Mac, Linux. Alright, so once you have the Arduino set up and installed, you're going to want to open it up, and you're going to want to go to File and create a sketch new. And now I already have a sketch created here, and okay, so now we can get started. So if we go back to this GitHub link, we're going to go to Sailboat ESP8266. And then what we're going to do is we're going to open this up and we're going to take this code and we're going to put it into our IDE. Now you can try and write this out yourself and figure it out, but it's already here for you. And I'll explain how this works later in the video. Alright, so we take that and we're going to paste it in our IDE. Alright, now we can go and start to add our boards. So we're in the IDE, we're going to go and we're going to open up preferences, and you see right here it says additional board manager URLs. So what we're going to do is we're going to take the link for the ESP8266 and we're going to copy that into where it says board manager URLs. Alright, So once we have this added, our board should be good to go. So if we go to boards and we go to boards managers, which is the next step here. Well, the next step is downloading the Blink library, but so we're going to go to board managers and we're going to search for ESP8266. And right here we have it, and that's the black board that you're going to get with your Sailboat kit. And so we're going to install the libraries for that, and this could take a while, so we'll come back when it's done. Okay, so the library finished installing, and we can move on to installing. You see we have our Blink libraries right here. So basically what these are, this is like your checklist that you're going to want to go down to make sure that everything's installed properly. If something hasn't been installed, when you go to compile, this line, one of these lines will show up red, and they'll give you an error code as to, you know, what sort of went wrong. And yeah, so right now the next step is to go to manage libraries, and then we're gonna find the Blink library. Right here, Blink library. We're gonna install that. This one's gonna install quicker than the boards. Alright, so that's installed. Perfect. Actually, before we can compile, we need to select our board, and we need to make sure we go to Node MCU 1.0. So once we have that selected, it's going to compile. And this could take a while depending on, you know, the speed of your computer, how many libraries you have installed. Okay, this is set up properly. We know because we have these messages right here, and then it says done, and it tells you how much memory the sketch is used, and it gives you a bunch of other parameters. But yeah, basically if you see this message, you know that your sketch compiled correctly and it's ready to be uploaded to the board. Now in the second half of this video, this will be a hardware tutorial in which I will demonstrate how the project needs to be wired properly in order to properly power everything and have your control system set up. But some things about the code. So in order to upload the code to the ESP, you're going to want to click upload. I don't have the ESP Arduino, same thing. I don't have that connected right now, but if I did, I would click upload, and then you're going to want to go into the Blink app and get your custom authenticator, and I'll show that later in the hardware section of the tutorial, where you will need to email yourself the custom authenticator and put it into here, so that way the board, the Arduino board, the ESP recognizes your phone. And then, so this SSID and password, this is going to be whatever local area network that you're going to use. So you can use your phone's hotspot if you want to do this remotely, and then you would put, you know, your phone's name and then your hotspot password in there, and the ESP would connect to your phone's hotspot. But if you're testing this in, let's say, your school or at your house, you would put in the school's password or the school's SSID, which is the Wi-Fi name that you would see. So for example, if I were to go to networks, like this right here, whatever comes up on the Wi-Fi screen, that's what you would put into the SSID. And you need to make sure that it is perfectly matching. It is case sensitive, it is space sensitive, you need to match it up perfectly, otherwise this will not work. And then same thing with the password. And when you upload the sketch, and then you can open up the serial monitor, which I can't do right now because I don't have an Arduino connected, but the serial monitor will show you whether your ESP has connected to the internet or not, and I'll go over that more on the hardware side of the tutorial. But yeah, this is the software side. Set up, your ESP is ready to go, the sketch is ready to upload onto it, and you're ready to test your Sailboat electronics.
Alright, so at this point, you guys should be all done installing all the libraries and setting up your Arduino IDE, and you should have the code that we've written, or you could have written your own version. But now we're going to get into how we actually wire and compile on the Arduino and make these electronics work. So in your kit, you should have gotten a servo, an Arduino, a battery pack with 3 AAA batteries, and some jumper cables. And so, in order to flash your code onto the ESP, you're going to need a micro USB cable. So, I'll demonstrate that now. So, again, we hit upload on our sketch. I need to get my board permission. So we hit upload on our sketch, and that still doesn't work. So our sketch should be uploading, and right here, if you see this message, it means your sketch is uploading, and we should be good in a minute. Alright, and now at this point, we can open up our serial monitor. Make sure we're on the right baud rate. And we hit reset on the actual board in case we don't see any output. And so right now, it's searching for my hotspot because I haven't enabled it yet. At this point in time, like I've gone over earlier, you can configure it to whatever local area network you want to use. So if you're inside your school, you can use your school internet, or what works best when you're actually out and testing these things is using your phone's hotspot. And so we just enable our hotspot and we wait for the ESP to connect. And so as we see on the command prompt, we have our ESP connected, and it's given us its local IP, and it's connected to our hotspot. And again, on my phone, I see that I've been connected. And so now we go into the software, and we won't get an ESP online error. So now we can begin to wire up our project. So on the servo, we have a ground, which is the brown pin, a red, which is the power pin, and an orange, which is a signal pin. I'll attach some graphics on screen right now, as well as in the email, about an official wiring diagram, so that way you can see these things laid out, and it'll be easier to follow. But so in order to connect this, the servo is going to need to receive signals from the ESP as to which angle to turn to. So we're going to take one wire, and in the code, we've already configured which pin we're going to use. And so in my case, I'm using D8. So we need to find D8 on the board, and we need to connect it to the pin. So as we see here, I'm able to just put this jumper cable into this slot, and that's because I'm using a breadboard. So in a breadboard, you have a bunch of different dots, and in these dots, they're all aligned, and so each one of these holes is connected to each other. And so if I put a pin in here, a pin up here will receive the same signal as each other. So I put the whole ESP in, so that way I can easily test my connections without having to do any soldering. Now in this case, this battery pack has already been soldered, and so you'll see here that there's a joint where one wire comes out of the battery pack and splits into two. So these two wires are going to power your ESP and your servo. And because, if we notice, on the ESP, we only have an output of 3.3 volts. And so the servo needs 5 volts. And so in order to remedy this problem, we can use this battery pack, which has 3 AA batteries in series, which will give us a total output of 5 volts. And so we're going to need to both power the Arduino and the servo off of the same power, so that way we can put it on the sailboat and it'll be able to be remotely powered. Alright, so I put the red wire, which corresponds to the positive lead on the battery pack, into the servo here, into the servo's output. And let's also make sure to switch our battery pack as off. That way, if we have any mistakes in our wiring, we won't fry our electronics yet. So now I go to the black, which is the ground on the battery pack, and I plug that into the ground on the servo. So now our servo is powered. So then we take our ground on the battery pack and we plug that into the ESP. And then if you have your ESP plugged into the computer, I suggest you unplug it, just so that we don't A, fry the ESP, and B, potentially cause damage to whatever USB port your computer is plugged into. So we disconnect that, and then we take the positive voltage and we put it in the V-in pin. Now again, this will be on the diagram, but on the ESP, it's this pin to the right of the USB pin. It's the V-in pin, and then next to it is the ground pin. So we make sure that's wired up, and then our servo should be good. So if I turn this on, we saw the little light flash on the ESP. We know it's powered. We hit reset. It powers up. So now I go back to my phone. I make sure that I see one connection on my hotspot. And we can go to the Blink library. And we're now able to control the servo with the iPhone. And so now the Blink library has some setup to do. You would just, so we would start with a blank board. And on this blank board, we have nothing on it. So in order to add things, we touch on it and we can configure with a whole list of things. But in this case, I want to use a joystick. So we have our joystick right here. Now our servo can only accept values from 0 to 180, as I've explained in the code. So we need to change it here. And in the code, we've specified that we're using pin V1. So we change this to V1, and we want our range of values to go from 0 to 180. So we change the top bound to 180. And we hit play in the corner, and we have control of our servo.
I'm just thinking about
And if you have any trouble configuring any of this wiring, just be free to shoot me an email, or ask your teacher to shoot me an email, and I'd be happy to get on a Zoom call and help, or help over email, or whatever issues you guys might be having. And yeah, that's all I have. Have fun building these things, guys, and I'm excited to see your videos at the end.
Now that you've built your sailboat, it's time to start your submission. To submit your sailboat design, you and your team are going to create a 2 to 3 minute video showing your sailboat, explaining design choices, and showing your sailboat sailing. When your video is complete, you can upload your submission as an unlisted YouTube video where the Engineering and Technology Club will stream your video at the live viewing where the other competitors, judges, and spectators will be watching. To determine a winner, the judges will score each submission using the score chart provided by the club and will proceed to determine a winner that will be announced later in the event.